back for some maths. We're still looking at shape, but we're looking at identifying different orientations of lines within shape. So I've got two lines facing different directions. We've got a horizontal line and a vertical line. So it's really important that we can identify these and not get them mixed up to start with. So we've got our horizontal line, which goes across from left to right, and it has to go exactly across from left to right. And then we've got our vertical line, which goes exactly up and exactly down. And it's almost, when you put them across, they're like the points of a compass. So it has to go exactly up and down and exactly left to right. We can't have them, because there is another type of line. We've got our diagonal line. So a line that's neither kind of exactly vertical or exactly horizontal. And we could have a range of diagonal lines, but we're not looking at diagonal lines today. But we still need to know what they are, so we can identify, well, if it is one of those, it means it's not one of those, because that's what we're looking at. But more specifically as well is when these lines meet. So when we have a vertical line and a horizontal line meeting, it's what we call perpendicular. So I'll draw my example, and we should know what that means is they meet and form a right angle at exactly 90 degrees. So you can see there I've got my vertical line and I've got my horizontal line. And that can also happen in a range of different scenarios. It could be upside down. If I continue these lines, we should also know that around a point, we have four of these, four right angles. So four lots of 90, or four lots of 90 degrees. We've got our quick maths. We should know there's 360 degrees around a point. But it just goes to show that we can have right angles in a range of different orientations. And if I'm really careful with my squared paper, we can actually have right angles that aren't necessarily following the lines, but there's still a right angle there, because the opening, it's all about the size of that opening. So the point there to there is exactly 90 degrees. So we're going to look at, first of all, identifying vertical and horizontal lines, and then finding right angles, or where they meet at a perpendicular point. So if I have a really generic shape, I'll just draw a boring rectangle. I'm going to state that these two on the side are vertical lines, so I'm going to put a V next to them, just to make it nice and easy. We don't want to put the V over the line, because that means something else. And then I know that these are horizontal underneath. And then the only other thing I'm going to talk about is our right angles, and I'm going to show that actually I know there are four right angles where these lines meet in a perpendicular manner. And it's only interior angles we're looking at. So you're going to identify the lines, be it vertical, horizontal, not necessarily diagonal, but you can put them on if you like. And then interior angles, we're looking for right angles, so where they meet at 90 degrees. So just like I've done, I've got some weird and wacky shapes. So feel free to try and draw them out if you can, or just pause the video and have a think and have a look. And actually, I want you to identify vertical, horizontal, and how many, or if there are any, right angles as interior angles within those shapes. Okay. Let's first of all put in our horizontal lines, so all the lines going across. So I know that one's going across exactly left to right. I know that one is underneath. This one is above. Got another one there, another one there, and another one there. Our vertical lines, one over here. Of course, that's a diagonal line, so I'm going to leave that one alone. There's a vertical one. Diagonal again. Vertical, horizontal, there's a vertical and only a little one, and diagonal. And actually now that makes the job of identifying our right angles much easier, because we know it's where a horizontal line and a vertical line meets, not where a horizontal and a diagonal, or a vertical and a diagonal. So I already know that that isn't going to be a right angle there, but I know this one is, because I've already identified those as horizontal and vertical. So that had one right angle. Over here I've only got one vertical line, but two horizontal lines intersect it. So we should have had two right angles. And then again, being really patient, one in this corner, and actually only one in this corner. Now you could argue there's one on the outside, but that's an exterior angle. We're only looking at interior angles, which mean inside the shape. So whether you've got square paper or not, have a go at drawing some really weird and wacky shapes, and then identifying horizontal, vertical lines, and then where they meet, showing that they're 90 degrees and they meet in a perpendicular manner.